Hey everyone, welcome to part 4 of the Azure Masterclass V2, Resiliency. So the goal of this module is to walk through the things we have to think about to make our service, our application available, resilient to different types of failure or even malicious intent. So what are the types of resiliency? What are our options around them? What are the constructs in Azure I can leverage as part of my resiliency? We think of different blast radiuses, things that go wrong, well, they have a certain blast radius of the things they impact. So what are some of those blast radiuses and the constructs that have walls between what is that blast radius? Thinking about backup, how can I do backup? And never forgetting backup and replication are very different things, and we're going to dive into that. Then also thinking about, well, what are those replication capabilities? And if I think about using many different physical locations around the world, so regions, how do I get a single endpoint for the various client services? We want to look at all of those things. Now, when we think about this from the start, what are we actually trying to protect ourselves from? What are the types of failure that can actually impact us? And obviously there's software. Now the software itself could be the application. It could be the operating system. It could be some runtime. And this could be a bug in the OS, a bug in the application. It could be a crash. It could be a memory leak. It could be CPU pressure. But there's something that fails either in the app or the runtime or the operating system, some middleware it's leveraging. So if we draw these out as we start thinking about the components then, well, I have my application that's providing the business value that may be using some runtimes. And then I think about, well, I have the operating system, Windows, Linux, whatever that might be. So then I can think about, well, those things can fail. Hardware can fail. A disk, a server, a power supply unit, a network switch, which will probably impact a whole rack. It could be an entire cluster. Some controller has a problem. Some entire physical data center has an issue. A facility. So there's different ranges of impacts and things that could fail. Obviously, if the entire data center goes down, well, it impacts our rack and our node as well. But there's different aspects to that. So that application, the operating system, well, that's running inside a virtual machine. That virtual machine is running on some type of host. Now, when we think about the hosts, remember also it's probably using storage, which is on another cluster. Well, that could have different types of failure. And then I can think of, well, this host is running on some kind of rack. Lots and lots of these blades, servers running in a rack. Well, that rack has things like a top of rack switch. It has power supply units, often redundant, but still things that can actually fail. And then this rack sits inside some kind of data center, which itself is based in some kind of locale. It lives in some kind of region. And whether this is the cloud or on premises, you have these same things that can fail. When I think about a data center level, or maybe sets of data centers, realize this has things like power requirements, substations bringing in power. It has cooling requirements. I need water to be able to cool. And obviously, I need network to other data centers, to the internet. So all these different things are required for my service to actually function. So I'm trying to protect against software failure, different types of hardware failure. Corruption. This could be accidental. Hey, I accidentally deleted something, or I accidentally did an update on too many rows in a database, and now I've changed a whole bunch of things. Well, that's not a failure of hardware. That's some logical corruption. And if I had replication, that logical corruption would be replicated to the copies as well. That's why replication isn't a replacement for backup. Could be malicious. Hey, someone has come in and they've encrypted all my data so they can then ransomware me to pay money for them to decrypt my data. Some kind of other attack. I want to protect against maybe a denial of service. Someone's just bombarding my service with requests and it's making me unavailable to legitimate clients that provide my business and actually get money. Maybe I'm trying to protect to make sure I'm meeting regulatory requirements. Hey, I have to be available for a certain amount of time. Maybe I'm offering some service to the world, telephones, for example. Hey, there's regulatory requirements around availability so people can call 911. Maybe it's, hey, I have to make sure I maintain a certain amount of data. And I also need to protect against humans. Now, obviously, humans play a part in different types of attacks and accidents. But accidental things, insufficient testing, problems being introduced without proper change release, many problems are actually due to human error. Hey, I went and changed this route. I went and changed this DNS setting. Oops, that was a mistake. I changed the database schema. I changed the software. It's really important we have things in place to help protect against accidents. Now, malicious intent is very hard to protect against. I can have certain gates. There's things I can do, reviews and approvers. So there are things I can do, but often accidental things happen. Imagine I have an orchestration solution when I accidentally target 1,000 servers instead of 10 servers. That has a huge impact. So we'll say human error, but make sure if we do have those sorts of systems, we do think about, well, what could I do to help protect against those human type errors? What could I do to maybe prompt, say, hey, you're targeting this production environment, you're going to impact 1,000 servers. Are you sure you want to do this? Maybe you throttle it to say you won't let them have that kind of impact. So what can I do against infrastructure type failures? Well, I can copy it somewhere else. That's a fairly obvious one. So if I have stateful data, and you're going to hear me talk a lot about, well, is there a state or is there no state? Because if there's no state, well, I can just have other copies running somewhere else. It's state, some durable data that's really important to the functioning, like a database. Well, I have to make sure I'm copying that data. But if I have a service that doesn't have a state of its own, such as a web front end, that's generally stateless, I don't have to think about copying it. I can just have different instances running somewhere else. So potentially, hey, to protect against an infrastructure failure of a stateless service, I don't have to copy or replicate anything. I can just have it existing and running somewhere else. Now, when I say you don't have to copy anything, realize very often we create infrastructure today based on some infrastructure as code, so some template. Maybe it's using an OS image or a container image stored in a repository. Well, obviously, those things I need to make sure are available and are replicated and enable me to create things from those artifacts. I don't want to rely on something in the primary location if that's then gone down. But potentially, I don't have to replicate anything from the service perspective if it's stateless. Maybe I just have a previous point in time copy. I have some backup on different media than the primary source, and I could restore to a new set of disks, for example. So there's different things I could actually do here. The point is, we can mitigate using different options depending on the type of threat we have. Often, we're going to have both the types of protection to protect against different types of issue. I want backups on some different medium, but also I might just have replication if there was some just disk failure. So a backup lets me go to previous points in time. So a logical corruption, a backup protects me from that. A point in time snapshot protects me from that. But replication doesn't, because replication is going to copy any change I make, any logical replication problem will just get replicated over. So depending on what I have, the different solutions will apply. So I want backup and replication to handle different things. Replication is great if there's some sort of infrastructure failure and I need the data copied so I can start it somewhere else. And we want to make sure we have good monitoring. I want to make sure I have that really good monitoring so that I know what is a common usage pattern. So I know when I start to see some trend deviating outside that, which may indicate, well, there's a problem. There's a memory leak. There's too much CPU pressure. I can go and investigate exactly what's happening. It may show sign of a problem. That observability is really key to many things we think about for our application lifecycles. When we talk about DevOps, observability and understanding not just the health of the system, but how something is being used helps us, well, where should we focus on features? What's getting the most bang for the buck? So if I think about this idea of the things that can happen, realize we're focusing right now on things that have state. So if I think about, okay, let's take, it could be a disk, it could be a database, whatever that is. But there's some data that I care about on there. So the key thing is it's something with state and we care about that. We can't recreate it. Sometimes a tier may have caching. Well, it's inconvenient, but I can re-warm up the cache. I can cache things again. It may impact performance, it may slow down starting, but it's not essential. Whereas something where it is the actual store of information, I need to make sure it's safe, it's durable. So things I could do here is, well, I can absolutely copy it. I can copy it so it's available on a different set of infrastructure. The other thing I could do is really in place typically, and I'll draw it as a little camera. It's supposed to be a camera. As we know, I can't draw, but I can take a snapshot. So a snapshot creates a point-in-time view of the data. Typically, it's delta-based. It's only going to save the changes between different snapshots, which means it inhabits the same media. It's on the same set of disks. So snapshots won't generally protect me from a disk failure. The snapshot would get lost or unavailable as well. But it would protect me from a logical corruption. If this data was corrupted in some horrible way, so let's say, hey, I have a snapshot, and what this snapshot has is, at this point in time, 101101, if there was some logical corruption, something bad happened, malicious or accidental, and the data was changed, so this becomes a 0, well, replication, copying, would now make this a 0 as well. So replication doesn't help against the logical corruption, but my snapshot, that's a point in time, that doesn't change. So I could now roll that back and recover. So that's why snapshots help protect me from that type of, hey, logical corruption, changes to the data. It's why if you were attacked, what ransomware people will try to do is identify, hey, do I have snapshots? Do I have backups? And they'll try to delete them. So you can't roll back to this unencrypted state. They want you to have to pay them to get your data back. So if I think about this, the solutions are replication. So if I want to copy it somewhere else, the actual solution is replication. Now, when we think about replication, there's actually different types available to us. We do have that previous point in time copy as well. We have the option to do backups. Now, one of the differences between snapshots and backups commonly, but even this, there are some variations now because some backup solutions you see will use native snapshot capabilities of the service. So you're using a backup service, but the backup service is really acting as an orchestration tool to create snapshots on some kind of schedule. But traditionally, backups would take the data and store it somewhere else. So now it's separate from the original source media. And the key point is, when I think of replication and backups or snapshots, they are not interchangeable. It is not a, oh, should I use a backup or should I use a replication? Again, they're protecting against two very, very different things. Backups, snapshots are a previous point in time. It's protecting against those logical type corruptions. Replication is helping protect me against types of infrastructure failure because it's on a different set of media, but a logical corruption would copy over with it. So we will add in here, obviously another option is here, I can do backups. And again, the key difference would tend to be a backup would be a different set of media. So it would actually write to some kind of vault. It has its own set of media where it will store those various point in times. Now, when we say this copy, there are different types. So I can think about replication. Now, there are other things I can do. I could literally do a copy. I could have an automation job. I could manually do it. And I could periodically copy the data. I can even do, hey, what's changed since the last time I copied the data? Replication tends to be more built into the service. It's actually looking at maybe a change feed or logs to see what exactly has changed, and it just ships that over. But the thing is, there's different requirements I might have for this copy. Very often, if this is a big distance, like a different region, a different physical location, this replication will be something called asynchronous. And we're going to go into more detail later on. But the whole point is if I'm an application and I make a transaction against the primary, well, as soon as it's durably stored here on some physical media, it gets acknowledged. And then maybe on a schedule or as quick as it can, it sends it over here. And it's really because, well, it's a distance away and it adds too much time to a transaction. But how often I send this and how acceptable this is going to depend on a couple of factors I have about my application's state, that durable data. One of the things we'll hear about is something called a recovery point objective. And this is really saying, in the event of an unplanned disaster, because generally a planned disaster, I'll shut things down nicely, I'll finish off any replication, then I'll switch over. I don't intend to lose anything. But unplanned, I may lose data in an asynchronous replication. So recovery point objective says, well, how much can I lose? If I had a 5-minute recovery point objective, I can lose up to 5 minutes of data. Then you have a recovery time objective. And this is how long till I have to be running. I.e., how long can it take me to start up the DR environment? Maybe it's an hour. So I can be down for an hour. Sure, people can't get to my service, but you have an hour to fail over in the event of an unplanned disaster. My recovery point objective is still 5 minutes. I only want to have lost 5 minutes after that hour it takes you to start up, but they are two very different numbers. There may also be an SLA, a service level objective. This is generally a percentage, and it's, well, what am I guaranteeing, maybe contractually, maybe based on some financial, on what the availability of this service would actually be. And the whole point when we think about replication, the region this is asynchronous, is this over here. If this was one region, this would be a different region. This would be region 2. So the whole point is between this region here and this region, well, I want a big distance. It's no good having a disaster recovery location, a second location, just over the road. Because, well, if there was actually a problem, it may impact my DR location as well. It makes it essentially useless. So I don't want to think about, hey, I'm just going to have a DR location 5 minutes away. If some tornado whips through or there's a flood, it's just likely to impact my DR location as well. So I want typically hundreds of miles between a primary and a DR location. Now, we do have this idea when we have this idea of the app, and I drew the app over here. Within a certain region, it will be very common that I would actually not just have one copy of the app on a different rack. I'd have other copies of the app, multiple of them. And I would put these in some kind of, it might be a cluster in the Windows world or whatever, but it's some kind of farm. They're all offering the same service. It's a farm or it's a set. And this, when I have multiple instances very close together, if there was a copy of the data, it could be synchronous. It's going to do it at the same time before it acknowledges the record. But I think of this as high availability, HA. These could all be offering the service. They could share a durable state. This is high availability. When I think about a different location with a big distance, this is more disaster recovery scenarios. Now, absolutely, I could do an active-active, and we're going to talk about that in more detail, but it's just harder to do that type of thing because data comes into it. And that whole how do I handle data and how do I make sure I'm consistent looking at the right version actually gets pretty complicated. So that's things I can do up against infrastructure type failures and even different types of corruption. What do we do against the humans? Well, human beings should have almost no contact with production. And if I want to be efficient, they really shouldn't be doing much against UAT environments either. I want user acceptance testing environments, sort of QA and production to be very similar to make sure my testing is valid, my processes are valid. But I definitely do not want human beings logging onto production servers as any kind of normal thing. Maybe in a disaster, they're actually trying to fix something. Sure, then they may have contact. Outside of that, human beings shouldn't touch production. It's generally some human introduces a problem. Now, as I did mention, automation is fantastic. Now I could sit at a console and I could run a command against 1,000 servers. But realize all that great power really amplifies also my ability to do great damage. If I do the wrong thing, I can accidentally reformat 1,000 servers instead of the 2 that I meant to. I target the wrong cluster and I redeploy a new version when I didn't mean to. So we'll say human error for those things. But it's also important that when you start providing those sorts of systems, you should have safeguards. There should be the idea that if I am targeting, and you can flag different types of environment, you could flag the number of systems that would get impacted. Maybe, hey, it's above 10% of your overall amount of servers, flag it. Are you sure you mean to do that? This is what it's going to do. Maybe I require a second person to check that, to perform a validation on that before it will actually go through. Because humans do make mistakes. So are my orchestration tools human-proof? First of all, don't just make some fantastic orchestration tool that could target the entire environment without some checks and balances put in there. I want some person to do a secondary check, or at least clarify to the operator, do you sure you mean to do this? But use automated deployments. Someone shouldn't be copying a piece of software to the production servers. They might copy the wrong thing. They don't follow the right process. They don't follow the right change control. I want automated validation. I want something going through. And now this is a more of a DevOps conversation. We will talk about DevOps later in this course. But my whole thinking here is if we were to think, okay, well, this is the environment, for example, it's all going to be focused around the idea of some version control. Now, the primary version control we use today is Git. So this is a version control solution. Enables me to go back in time. I can view different versions of the code. I can have different branches, different projects maybe I'm working on, so different teams can work on different elements of the features, and then I bring it back together. But the way this would now work is the human being, the dangerous flesh person, they sit at their machine, they're doing their work, they make the changes here. All of the changes. So all of the elements, be it the application source code, maybe it's my infrastructure. So a template is used, infrastructure as code, to describe I need a VM, I need a virtual network, I need a container, I need these firewall rules. Everything is done as code. No one is manually clicking things in the portal. Maybe it's my database schemas. Everything is done as code. They make the changes. Maybe they can do some local testing, and then they do a commit. So commit takes their copy, because they have a local with Git, they have their own version, they can make changes locally. When they're ready, they commit it. You want to do it very frequently. It would get merged in with other people's changes. You do this very, very often so you quickly find problems. That's the whole point. But then off of this version control, when a commit happens, we kick off a pipeline. And the whole point of the pipeline is it does various things so we don't have to. So you have this long pipeline doing various different things across all different environments. But the first thing it might do is, well, hey, I'm checking for any bugs. Bugs may be in my code. There are technologies that can take code and convert it to a type of data. So we can go, am I doing some common coding mistake? Am I just accepting some string a user types in and adding it to a SQL command so someone could do a SQL injection attack? Same for HTTP. It's looking for that. It's looking for, hey, you're using a dependency that has a vulnerability. Shift left, the security, try and find things so you're going left in the pipeline as early as possible to find problems. And then, okay, let's build. When we build, we're going to push it to some kind of artifact repository. So this could be VM images, it could be container images to a container registry, whatever that might be. And then it will push it to maybe a dev environment. Once it does that, then you have some automated testing going on. Now, between all of the different environments, so you go dev, you're going to have gates. So between all the different elements you have, it could be a quality gate. So, hey, it has to pass the dev test. There has to be less than, 10 work items raised over a 24-hour period. Whatever the gate is, it could be human. Hey, it goes through, and then once it passes that gate, well, then maybe it goes to a user acceptance testing environment, another gate for that environment. And then eventually, hey, maybe it also auto-deploys to prod. Depending on how often you are doing these various things, how often you're pushing releases, it's going to depend on, do I automatically push to prod? Some environments, they're constantly making changes. Everything goes through. But the key point is you have a lot of testing going on, automated testing, different types of testing, smoke testing, integration testing. I want to get high confidence that everything I'm doing is going to work out. And when I think about deploying, especially when I get to production, we generally are not just going to put the change into production. What we'll actually see is there are different types of deployment patterns. Yes, I could just push it to production, but if there's a problem, I'm stuck that I've impacted everyone and I can't roll it back very easily. So that's generally a terrible idea. So one of the things I might do is a canary. If I have those idea of multiple servers, maybe what I do is I just push it to one of them. So it's a very small percentage. So I would find if there's problems, people using that version experience a problem, I'll flag it that much earlier. Maybe it's rings. I have increasingly larger parts of my population. So I start with a small ring, then the next bigger ring. So as I gain more confidence, I expose it to more and more people in the company. Could be blue-green. The idea is I have two different environments. And what I would do is when I've got a new version, I push it to the new environment, which is staging. I warm it up if there's any caching or code has to be compiled just in time, whatever that might be. And then through load balancing, I switch people over. I might combine that blue-green with that idea of almost rings. I move a portion of people over via the load balancer to the new environment until everyone's moved over, in which case the old environment now becomes the next staging environment. And if there's a problem, I can just load balance and switch the people back to the original one. So failback is very, very simple. Sometimes it's a feature toggle. So everyone goes to the same code, but based on some client setting, depending on the feature toggle, they will or won't see some new piece of functionality. I can also do A/B testing where, hey, I don't even tell people, but a portion of them gets a new experience so I can see if it works out. So there's different things I can do. But the whole point is we never just deploy en masse to production. We want to break it down so that we get confidence that the code is good. We start off in dev, then we have UAT, and even in production, increasing parts of our population. But we always have a fallback plan. So when I think about all those protection things, well, we can use replication for hardware failure, replication for software failure, corruption, logical, backup or a snapshot. Some attack distributed denial of service. Well, there's different protections depending on what the issue is. If it's, again, a malicious that's going to do some sort of corruption, well, again, that idea of the backup or the snapshot, but it needs to be isolated. If there's someone doing a ransomware attack, chances are they've got some credential. So does that same credential have the ability to turn off backups and delete the backups? Then I'm stuck. So I want it generally isolated away through some means, either physically or from a role-based access control. The person who does maybe the backups is completely different from the people that deal with the service. So if one credential is compromised, they can't go and then disable the protection, for example. And then regulatory requirements, maybe have to keep data for a certain amount of time. And humans, we need processes. Now, avoid pets. Sorry, Ollie and Eddie, when I say avoid pets. I'm talking about the workload. I drew the idea of a VM. VMs are what we're used to. In the old days, we had physical boxes, we had an operating system. Virtualization solved a whole bunch of problems with wasted resource, but it's still an OS instance. It still has certain properties and configurations. And things will go wrong. No matter what you do, things will go wrong. Servers fail, OS instances get corrupted, bugs are introduced. I don't want some unique snowflake that requires care and feeding and attention, i.e. a pet. What I want is the idea that I can recreate anything. Everything is that infrastructure as code, be it the infrastructure of the cloud. Hey, there's some ARM template or Bicep template. If it's an OS, I can use declarative technologies inside like Chef or Puppet or PowerShell DSE to set up IaaS, to set up my application. Nothing should require manual clicks or have some unique configuration that, oh, if this box goes down, I'm totally messed up. Everything should be, you'll hear pets and cattle. The idea is I can replace cattle generally a lot easier than generally I would replace a beloved pet. That's really just the way it goes. If there is state, and you're going to have state, put it in a very specific tier portion of your application. I don't want it scattered around everything. State should be very carefully controlled of where it is, and that I can give the extra attention. But even then, I think about replication, I think about copies. So any individual database server, for example, I could still just recreate. I still want to think about being able to recreate those things. So I do not want these unique snowflake instances that if there's a problem, I have to spend hours troubleshooting. If it's broke, I delete it, I recreate it. That's the goal. Now, I have to understand in my environment, in my company, what are the applications that actually matter to my company is the first thing I have to understand. But then I also have to understand, well, what do they require to function? So what are they dependent on? And within these services, where is the state? I need to understand every element. I need to know my application. I need to understand, well, does it actually matter? Or if it's unavailable, it doesn't. Time recording software for my company. If it's unavailable, it's probably not the end of the world. My cart for my shopping service, that's probably a big deal if it's down. Where's the state? So again, I need to protect these things differently. What do I depend on to function? So make sure you understand what's critical, what's nice to have, and also, how do I get to it? Like, what are the interactions with this service? Now, there are things to help. There's things like Service Map in Azure. There's things like Azure Migrate can help work out what are the various dependencies between different systems. How do they communicate with each other? Because we could take a fairly standard traditional 3-tier, and this is not, microservices would have the same idea, where every function is kind of its own set of instances. So it's very targeted. But if it's easier to think about a more traditional 3-tiered application. So a 3-tiered app, let's say, for example, there's some load balancer at the front end. And that load balancer is because I want a single virtual IP, a single DNS name for clients to talk to. And then what that actually talks to is, well, the front tier, the front end. This is, for example, maybe a web tier. And this is focused on the presentation. And that web tier, well, it goes and talks to maybe another load balancer. And that load balancer has instances of the business service, the application tier. And the application tier, depending on the exact mechanism, well, it goes and then talks to some database. And that database hopefully has some replication going on, so it has some resiliency as well. Now, if I look at this, where's the state? Where's the thing I really care about? Well, it's here. That's the thing I would have to make sure I'm thinking about replicating. These, I could just have other instances of. I could even recreate them. This I need to make sure I'm replicating. These pieces have no state. Those, I just need to make sure I can recreate them. Hey, if they're built from some image or a container image, I need to make sure that repository or registry has a replication to another region, or at least it is available outside of the region where the primary sits. It's not that big a deal. But what does this app also depend on that I may not think is a core part of the app, but absolutely has to be there for it to function? Now realize, this is a fairly simple app. You may have way more complicated apps that even the best intentions in the world of the app teams, they just may not know that it relies on some other component hidden out there from eons ago. That's why things like the service map, Azure Migrate, to actually go and look at either API calls being made or network ports used can help me identify if there is some other dependency that I just wasn't aware of. But hey, this app tier may use the managed identity to actually authenticate and be authorized to talk to the database. Well, managed identity, okay, so this has a managed identity that has permission to talk to the database. Well, managed identity is powered by Azure AD. So now I have a reliance on Azure Active Directory. Well, actually, this has a secret it uses access signature to talk as part of this app tier. Well, that's stored in Azure Key Vault. Okay, so Azure Key Vault is also a dependency for this to function. It does a read. There's actually a firewall between the middle tier and the database. Well, that's a dependency. And it's saying I need to understand if someone goes and changes firewall rule, it could break my whole application from functioning. If there's a problem, we have a jump box. The jump box is the only one that can then RDP or SSH to the other servers. Okay, so I require that. Well, to get to the jump box, I have to do a VPN. Oh, okay, so the VPN is a requirement as well. You can see how quickly it builds, but you need to understand all of these elements to make sure I really am thinking about the true requirements, the true things I really have to protect, I really have to make sure is available in the environment. So really take that time, because you don't want to find out when you do a disaster failover. That's the worst time to find out, oh, I've missed something. I remember my early career used tapes. There were these square tapes on VAX VMS boxes. And one of the banks had to do a failover. When it turned out in the primary site, they'd upgraded their tape system. They hadn't upgraded the tape system on the DR site. They couldn't restore the backups. That was a bad day for many, many people. So I want to make sure I keep them in sync. I understand everything that's required. So understand my requirements. This is another really big one. People say, hey, okay, I've got my environment, I've got my architecture. But are you architecting correctly? Do you really understand the true requirements of availability of your, so how critical is it to the business? People will often say, well, my application's absolutely critical, it must always be there. Then when you start architecting to that, and it costs millions of dollars for example, they go, oh, actually, it doesn't need to be that. I can be down for 5 minutes. Okay, well, that changes a lot of things. So I'm going to have some service level agreement. Now, the services in Azure, most of them have an SLA. Now, how much you care about the SLA is going to vary. Realize what the SLA is. The SLA is a financially backed service credit. So I can go and pick a certain service, for example, if I go to compute and look at virtual machines, hey, I can see there are different SLAs available depending on, hey, am I using availability zones? I get a certain SLA. Hey, I'm using availability sets. Well, with availability set, I get a slightly lower SLA. Oh, a single instance, so it depends on then the type of disk. So these SLAs, the idea is if it doesn't meet the SLA, there's a certain service credit you get back. But you may not care about that. The few dollars potentially, depending on the service, may be inconsequential compared to the impact on your business. So the SLAs may give you an idea of what the expected availability is, but that service credit may just not be what you care about, ultimately. So depending on the criticality of your service, you're going to have a certain availability requirement. Now, when you think about this, you're going to weigh up different things. You're going to weigh up, well, what's the cost of improving the SLA, the availability of my overall service, against what's the cost of being unavailable for that time? Because maybe it would cost you 10 times, or let's say double the amount of money to go up a 9. So from 3 nines to 4 nines. So instead of 99.9% available, you go to 99.99% available. Maybe that's a few minutes difference. Well, that doubling the cost may cost you an extra $50,000 a year. Whereas not being available for that few extra minutes maybe costs you $5 in lost sales. It's not a good trade-off. Now, cost is not just cost of maybe sales. It may be reputation. There are other elements, regulatory. So there's many aspects to what is the cost. It's not just financial, but you have to weigh those things. Hey, what is the actual cost of not being available for a bit extra compared to the cost of increasing my availability? Now I have to architect my solution to meet or exceed the SLA I have agreed to. Whatever the application's SLA is, I have to architect accordingly. Realize this does give you an idea of what to expect for the Azure resource. Most of them are running on physical infrastructure. I say most, all of it. Some of it's built in software and it's over lots of boxes, but there are still boxes in the sky. There's a joke. There's no such thing as the cloud. It's someone else's data center. There's a lot of truth to that. Obviously, the cloud also offers lots of different types of service. It has great control planes. It's lots of regions. But if you boil it down, there's a bunch of servers in locations run by someone else that hosts your service. And the point of that is things will still fail. It's not magic. Boxes will fail, disks will fail, data centers will fail, cooling systems will fail, fires can happen. Maintenance is required. If I deploy a single virtual machine, they still have to periodically update the hypervisor kernel, for example. Well, they may not be able to live migrate, so they have to freeze your VM. They have fantastic technologies. VM preserving host update, VM-foo, will freeze it in place, doesn't have to clear the memory, reboot the box to the new image, and your VM gets unfrozen, but it might be unavailable for 30 seconds. It's expected. So there's planned and unplanned. It's almost guaranteed at some point. If I have a single VM, it will be unavailable periodically. It's just going to happen. So I have to make sure I understand my requirement and then make sure I architect accordingly to that. I'm going to have multiple instances of services. I'm going to have multiple components. Look at my picture here. For my service to work, I have to have the web tier, the app tier, and the database tier. So this is an and relationship. My service is not available if any one of these tiers is not available. All of them, and I have to have this tier and this tier and this tier. But notice we have multiple instances in every tier. Why do we do that? We have multiple instances for scale, so I can handle more load coming in, but also for resiliency. Because if this one was unavailable because of a failure or maintenance, well, I just need one of them to be available for this tier to be okay. One of these to be available for this tier to be okay. There's a synchronous copy, fails over, one of them to be available. Now it's going to impact my capacity if one is unavailable. It's not all roses, but assuming I've done the right planning and the right auto scale and some spare capacity, I'm fine if one instance goes down. So there's a big deal in what is my overall SLA of my solution, depending on, is it an and or an or relationship between the different components I have. And I did a whole video on understanding what is a composite SLA, and it's linked in the description. And again, the GitHub repo for this has all the extra videos I recommend. And I did a whole video on actually architecting to various types of requirements. But at a super, super high level, just so we understand the basics. I can think we're caring about SLAs. So an SLA is all about the availability of my service. So I could say I just have some component. And my some component has a 99% SLA. Now I realize that's a terrible SLA, but let's just say that is the case. Well, it's a percentage. So percentage is out of 100. So if I'm 99%, what I'm really saying is for my availability is 0.99 out of 1. But it also means, therefore, the chance of me not being available is 0.01. 1 minus 0.99 is 0.01. So now let's take our multi-tiered service. Let's assume there's 2 tiers, and I'm going to be lazy because I don't want to do a whole bunch of math. And the other tier, let's just say it's 2 tiers in this example, is also 99%. So it also has a chance of 0.9 to be available. But I need both of these to be available for my service to work. It's an and relationship, which means I have to times what is the chance of this being available and this being available. Well, 0.99 times 0.9 equals 0.98. So it becomes a 98% SLA, which makes sense. If I need multiple things, well, the chance of it being available relies on none of them having a problem. So my overall chance of it being available as a solution is going to go down if there's an and relationship between multiple things, because these have a dependency. But then remember, we drew multiple web servers, multiple application servers. Well, now consider I have a second instance here, same SLA as the individual instance, but this time, this is basically giving me resiliency. This is now an or relationship. I just need this here or this here. And this has exactly the same. Well, it's a 0.99%, it's there. 0.01, it's not there. But now think about, what do I care about? What are the chances of this not being available? Well, the chance of it not being available is, well, what's the chance of it's not available and this is not available? So I times the chance of it not being available, and then it's 1 minus that number. Also, 0.01 times 0.01 becomes 0.0001, which is 0.9999, or a 99.99, a 4 nines SLA. We like that. And that should make sense as well, because now what you've done is, what is the chance of this being unavailable and this being unavailable at the same time? It's very unlikely, which is why we get such a great SLA for now that tier. And you would have maybe the same on that tier. So you've got now a 4 nines and a 4 nines, but now you times 0.9999 times 0.9999, which would be slightly lower to get the overall SLA of this solution. But it gets better if I have multiple instances, if I have ors, and it's going to go down when I have ands. Now, when you sit down and try and work this out, remember, you have to consider every element. The load balancer has an SLA. Azure AD has an SLA. Azure Key Vault has an SLA. Make sure you think a firewall has an SLA. Work out the SLA of each of the OR components, and then you can join them all together. So there's a whole big discussion about how you think about this, but it's critical you really understand the true SLA. And again, I've got a whole video going through this to make sure you are architecting it correctly. So really, really think about those things. The next thing is test. And then test some more. Many things will start with the app testing. So the application testing itself. I want to think about unit testing, integration testing, smoke testing. Hey, I start this thing up and run it. Does it burst into flames? User testing, some hands-on with this solution. Test, test, test. And when I start thinking about testing, don't test to the specification. I've got the spec for an API. This is the type of data it expects. You can't just test to what it says it expects. You can't control what someone calling your API is actually going to send you. You may request 5 numerics. They send you a picture of a goat. What do? You have to test to that. And that's the job of the testers. Maybe they create a test harness so they can send weird and wonderful types of data. There's a joke about this. A software tester walks into a bar. They order a beer, 2 beers, no beers, 999,999 beers, minus 1 beer, a lizard in a glass. Random nothing. But they're going to try everything. And then a real customer walks into the bar and asks where the restroom, and the bar bursts into flames. There's a joke. And the point of that joke is, no matter what you think of, no matter how wild your test cases is, the users will always beat you. So you try and be as stressful and far thinking out there, but realize good design is critical to this, to try and think outside the box, to try and always have some catch that if something completely out of any thought process happens, your software doesn't fall in a heap. Load testing, making sure I'm understanding what is the load that I can take in my application. And once again, when you load test, you can't just load test with good. Bad data may tie up more resources. Imagine I'm some sort of service that accepts a session. Well, what if they initiate a session and then just drop off the face of the earth? They don't close. Well, the OS will keep that running for a period of time before it times out. It's tying up resources. What if you just get hit with loads of people come to your site, open up the page, but then don't do anything else? They've exited their browser 10 minutes ago. You're still tying up resources. What if someone's attacking that way? So you need to make sure you think about what are the impact. Are you having some lock? Are you eventually going to run out of threads? You're going to run out of locks? Are you going to run out of connections to a database? And your system's going to hang. I have to think of both good and bad things. What is the real traffic? That's why you hear these horror stories of something goes live and it collapses. They're like, well, wait, we planned for this. Yes, we planned for it and we tested for it with nice, well-behaving data, well-behaving clients. The real world is not that. So we have to think about those. Deployment process testing. How do we deploy? What's the impact? What are those deployment patterns? How secure and safe is that deployment process? What are those validation steps? What are the authorization steps? What are the approval steps I have in there to make sure someone can't attack my system by injecting something bad into the pipeline? How fast can I deploy? How fast can I fail back? Failover testing. I have to be realistic. I have to get confidence. Many companies will fail over and just stay running there. Even more, if they can, will try and just run active-active. There's no concept of active-passive where one site is just sitting there as disaster recovery. If I can I just be running in both of them? But that's going to depend a lot on my app architecture. Restore testing. Can I actually go back in time? Does it work? This may seem silly, but it's very realistic that we don't back up for the sake of backing up. We back up so we can restore, so we can go back to that point in time. Well, does the restore process do what we expected? Can I restore at the granularity I expected? Could I just restore a certain table? Or do I have to restore the whole database? Do I have to restore the whole server? Can I restore just an item? I have to feel confident in the restore process. Security testing. I have to really feel good. Again, we shift left with our security as much as possible, have it just baked in from the very go. Make sure I've not got some vulnerability and a dependency. I've not got silly things in my code, but we have security in the shift right as well. We have firewalls, we have web application firewalls. We have as much as we can. We have layers of security. We have great insight to give us as much resiliency as we possibly can. And through everything, we're monitoring. We're looking for changes. We're looking for shifts in our trend. This is an interesting one. Chaos engineering. As I mentioned, we will try and think of bad scenarios. Users will always outthink us. They'll always find things we never even considered. But what we want to try and do is get beyond the average client. And sometimes it's very hard, especially in the cloud, to emulate a failure. So chaos engineering is the idea of introducing failures into the system, actual failures. It takes down a node of a cluster, of a farm, of a set. It adds some latency between certain connections. It changes a DNS record. It does something, it breaks you to see what happens. Are you truly resilient against these things? If you're not, you're going to find the problem pretty quick. And it's painful, but one of the things we say in life, if something's painful, you don't want to do it more often until you get comfortable with it. Same here. Introduce failures into your process so you're comfortable and you build confidence that you're going to be resilient against them. So it's going to find issues, but as you fix the issues, it's going to build a lot of confidence that, hey, actually, I can handle this. I'm resilient against it. Now, when you start off, you're probably going to introduce failures into dev, into QA testing. You'll get more confidence that you are resilient, and maybe you'll eventually start to introduce them into a canary environment, maybe even production. Netflix are fairly famous for their simian army. They had different types of monkeys, Chaos Monkey, that would just randomly go and shut down servers in their production fleet. Well, it would find problems. I'm sure the person who wrote that was pretty unpopular initially, but it made the service resilient and gave confidence. They even made it open source, but I think it's dated now. But I think some of those elements have made it into other services that you can use to go and test this stuff. But Azure has its own. Azure has Chaos Studio. I can craft experiments that will do different things. It could shut down a VM, make an availability zones content unavailable, introduce some latency, inject a fault into a guest, put on some memory pressure. So it's all about, hey, I can introduce problems so I can get confidence that I truly am resilient. The mechanisms I've built in to balance and switch things over actually work. Again, you want to be careful because especially if you run the production, if it doesn't respond how you want, you've just broken something. But you can build up the confidence. And I would also urge, you don't want snowflakes, you don't want any unique individual. Think of human beings as well. Do you have a person that just things don't work without? So another nice thing to do occasionally is random 10% of the app team, you're unavailable for the day. You're zombies, zombie outbreak, you're not available. Can you still do what you need to do? Or actually that person there is the only one that has permission to do this thing. Now you need an emergency way to contact them if you do find that's the case, but it will help find if you do have some unique people that you just can't work without. So it's good to know both the machine side, but don't neglect the human side as well. Okay, so we talked about things breaking, blast radiuses. What are some of the things I can do to understand what are the different blast radiuses actually in my environment so I use them as part of my actual architecture? So we can think about fault domains. When I create some service, for example, so let's go, we'll think about this region. I drew this idea of racks within a certain data center. So if I expand that idea out, so obviously, yes, we have racks. So I can think, I've got, okay, a rack, another rack, and we'll say they're in the same cluster. Now, in cluster, I'm talking about the same maybe fabric controller for a certain set of racks. So these are all racks. And we could think about them as, well, they have their own power supply units. They have their own top of rack switches. So something could fail in the rack. So we can think of these as fault domains. Fault domain 0, fault domain 1, and fault domain 2. Now the way we can use these is we can use a concept called an availability set. And I'll create availability set 1. And when I create an availability set, what typically it's doing is over 3 racks, it's spanning 3 racks. And I just put services into the availability set. And what it really does is round robin, distributes them over these 3 racks. So what availability set does is it gives me resiliency against a rack level or a node level failure. But it's only doing this round robin. So I would not ever mix workloads. If I put multiple workloads in the same set, well, maybe all my DCs ended up on this rack, my SQL on this rack. So I'd always create separate availability sets for different workloads, different unique things, to make sure all of them get evenly distributed over different racks. So I never, ever, ever mix workloads in the same availability set. Create one availability set for each unique workload. Web tier app 1, it gets its availability set. Web tier app 2 gets its own availability set. SQL database 1 gets its availability set. DCs its, etc., etc. Now we typically draw 3 fault domains in availability set. Some services like virtual machine scale sets now have the ability to do a fault domain 1, which will just use as many as it can. Maybe it's 5, it varies. There's also a concept of an availability set of something called update domains. And this is typically between 5 and 20, and you can control this. The idea here is that fault domains are against a failure. Something breaks. But realize there's also maintenance activities. Maybe I'm rolling out app changes, Azure is rolling out changes to its hosts. Well, it can update one update domain at a rolling update at a time, so it only takes down, for example, 20% if I have 5. Or if I have 10, it takes down 10% at any time as it's rolling out those changes. So that's kind of a key important thing to understand. So that's one blast radius. It's giving protection at a rack level failure. That's essentially, that's a fire. It's giving protection against a rack level issue. That's what it's protecting me from. Then we have the concept of, availability sets use that. So for a VM, that's 99.95%. Availability sets use fault domains. Then we have availability zones. That's 99.99%. And the way I can think about an availability zone is those racks live in a data center set. Now I'm saying set because if I think about what does a data center need, well, a data center has to have power coming in. It has to have, that's supposed to be water, cooling, and it has to have network. And different sets have independent isolated. So yes, there's this data center set, then there's going to be another set of data centers that have their own power cooling network coming in. And this is completely isolated from the other data center set. And then they have another data center set. So they've got multiple of these data center sets. Data center set 2, data center set 3. And these are exposed to you as a user of Azure as availability zones. Now these are subscription logical specific. So in your subscription, so for my subscription 1, I would see AZ1, AZ2, and AZ3. A different subscription would also see AZ1, 2, and 3, but they may map to different data center sets. What is one subscription's AZ1 could be another subscription's AZ3. There is no correlation between different subscriptions, because otherwise everyone would deploy to AZ1 initially. It would get just burdened with so much workload. So every subscription sees different mappings to the actual physical data center sets for their availability zones. But the whole point is what a availability zone is giving you blast radius protection from is the whole data center going. So this protects me from a blast radius of the entire data center being unavailable. That's the key point of that. Now, not every region has availability zones. If we go and look, so this is the SLA for virtual machines. And we can see that we talked about this before. So an availability zone lets me have a 99.9% actually of these. But if we quickly jump over, then we have the idea of regions. And if we look at the regions, let me do that. Let's go back to regions again. If we go to the regions, it tells you, does it have availability zones? And many of them do. You're almost always going to see 3. Even if there were more than 3 data center sets, in your subscription, you'll only see 3. So if I was, for example, going to go and create a resource, and I'll just create storage account. Is that a good example? Is that a terrible example? So I make it zone redundant. That doesn't let me, that's actually a poor example. That's not a zonal service, I don't know what I was thinking. Let's actually just do a VM. That's easy. So if I do a virtual machine and I pick availability zone, I will see 3 zones. I won't ever see zone 4. Today, who knows what they might do in the future, but it's 3. And 3 is a magical number in computers because you think about quorum. If I was to think about quorum on the things I do, well, if I just have 2 of something, it's hard to do quorum. Who gets the winning vote? I want 3 votes to make sure it's never a tie. So you need 3 to be able to get quorum in traditional senses. So we have availability zones to give us that capability where I now have these completely separate, and you see 3 in your subscription. Now, obviously, those zones live in regions. A region is defined as this 2 millisecond latency envelope. So I can think about, hey, all of this thing I just drew here, well, this is actually in a certain region. Maybe it's South Central US. And you can think about the latency envelope of a region is typically a 2 millisecond round trip window. So they're all fairly tightly packed. They're within a latency envelope. There is no set fixed distance between availability zones. You'll hear some people say it's 10 miles. It's not true. There is some efforts that have been communicated that some regions may be trying to get a certain distance. There is no guarantee of distance between availability zones today. It's not there. And then obviously there's multiple regions. So then I could think, well, then there's region 2. I might use multiple regions, and it's definitely encouraged. And what I want to do is have a really big distance between the regions I use. Because I want to make sure if there is some problem, it doesn't impact both. So big is probably hundreds of miles. And then this is made up of data center sets. Maybe this region supports availability zones, maybe it doesn't. But there's a whole set of different infrastructure there as well. So that's the point when I think about leveraging the services is, hey, I have different blast radiuses within the region, but I also then think about using multiple regions so I have resiliency even if there's some huge, maybe natural disaster that takes out an entire region. Microsoft do pair the regions. Now the pairs, you can go through and see. There's they're generally within the same geopolitical boundary, i.e. it doesn't cross a certain country's borders. The exception to that is Brazil South, because at that time, there was only one region in Brazil, so it pairs with South Central US. South Central US does not pair with Brazil. South Central US, if we go and looked, pairs with North Central US. So that's where it would flow from. There are some regions that actually don't have a regional pair. So for example, Central Qatar does not have a paired region today. So what's special about the paired regions? Microsoft rolls out updates to its services, fabric levels, different types of resource providers. They do not roll out the same change to paired regions. The idea being, hey, we roll out some change to a resource provider, it breaks something. If customers are using the paired regions, they wouldn't also be broken in their DR region or their other active region. Some services natively replicate, like storage accounts. They have GRS replication. It replicates asynchronously to a paired region where there's 3 copies of your data as well. Azure Key Vault replicates data to the paired region. So there is some native pairing, but there's also typically lots of other things you can do. You don't have to use the paired regions. A lot of the benefits I can do other ways, except that guarantee of not deploying the same change to the providers at the same time. That's today fairly uniquely tied to the paired regions. You might also hear about proximity placement groups. This is not a resiliency constraint. A proximity placement group is, well, sometimes, and if you looked at this, you would say, well, an availability set, you just said they're in the same cluster. So that means they're fairly close together. Maybe, but if you look at the Azure Fabric and the controllers today, it could actually span physical data centers within the same cluster. That would be possible. So it's not actually a guarantee that they are close together. Availability zone, well, they must be pretty close together. Again, they're different physical buildings. It's not a guarantee of proximity. These are designed to be separated. They're designed to have isolation. It's not a guarantee of proximity. So proximity placement group is designed to say, I need things close together. I can create a proximity placement group, and then when I put things in it, they're going to be close together in terms of network hops and latency. So it will, if I put multiple VMs that are very, very chatty, I need very, very low latency, I can pin a proximity placement group to a certain availability zone. It would then be in a certain portion that is a certain network hop and latency away. So I get very, very low latency between those workloads. The other constructs are not proximity based. Okay. I mentioned replication quite a few times. I've talked about asynchronous and synchronous. What's the difference and why do we care? And it really boils down to the fact that if you think of light, well, light's not actually as fast as we would like. It's not instant. We hear at school about this, was it 186,000 miles per second? Well, that's in a vacuum. When it goes over fiber, I think it's about 30% slower. So it's more like 125,000 miles per second, which still seems pretty nippy. I'll give you that. But realize it's also going through switches and routers, and they have to do calculations and they add latency. So it's not instant. As we increase distance, we increase the time our network communications take. So we increase our latency. And that really is going to impact our ability to send data. And so we have 2 types. We have the idea of asynchronous. Here, the transactions are committed on the primary as they're created, and then they're sent to the secondary as quick as they can. So this means it has no real impact on the primary performance, but there is a risk of data loss because it's committed the transaction to the requesting application before it sent it to the other location. So if there was a disaster, it's not sent it to the other location left yet, I could lose that data. Synchronous transactions are committed to the second or third, whatever it is, copy durably before that transaction is acknowledged to the requesting application. So this means it could impact performance because it has to now write to the secondary copy as well, but it guarantees I can't lose data because the application won't get that acknowledgement until it's been durably written to the other instance. Because of the latency across locations, we're typically going to use asynchronous communications because we can't afford the performance impact. So if we draw this idea out, we can take these two regions, for example, we'll take the same idea. So imagine now I have my database. So I have my database, and I'm drawing it right into the database. I realize sometimes it might write to the log file and then lazily write to the database. It doesn't matter in this example. So here we have our primary copy, and we have some application. So we have an application doing some operation. So they're doing a transaction. Wants to do a write. So it's doing an update or a create, or it could be delete. It could be delete operation. So this is step one. They're doing the transaction. If it's synchronous, remember the same region, there's another copy. So this would be synchronous. It would also make the change here. So it durably stores it, durably stores it. It gets a yes, I've done that back. And then, only after it was durably written here, do I acknowledge it. And the app says, okay, that's good. So this was a secondary. Because that's all in the same region. There's super low latency between those. But maybe I have another copy all the way over here in this other region, hundreds of miles away. So for this, I have to use asynchronous replication. In fact, let's use a slightly different color. We'll do async. This could be exactly the same. I could have both, and I probably would. For high availability, I have a copy in the same region. It's sent the acknowledgement. That was kind of the step 5. It sent the acknowledgement back. Now, when it gets around to it, as quick as it can, it sends it to here. And sure, it sends back, oh, I've done it. But the app doesn't know or care. There's nothing else happening. Yes, it was sent as quick as it can, but there was a lag. So you can get the idea that in the synchronous world, if this server just suddenly burst into flames, well, it was written here as well. Or the app wouldn't have got the ACK back. So if this did burst into flames, well, it wouldn't have got the ACK. It would redo the operation to the secondary. But if this whole site went up in flames instantly, well, the app would now try and talk to this one, but this transaction it just wrote may not have replicated yet. So that data could have been lost. But its performance has not been impacted by this because it doesn't have to wait until it went maybe 30 milliseconds over here and then got the ACK back before it gets its acknowledgements. It can't afford that latency. It would slow down the performance of the app too much if every transaction added 60 milliseconds of latency, whereas this might be sub-millisecond. So it can afford, for this extra durability, I'm willing to take that. So we'll see synchronous within a location. We'll see asynchronous across locations. So that's a very, very important distinction to understand about how these services will actually function. So that's really the core goal around those. That was weird. Come back. All right. So we use asynchronously across regions. Azure resources will use these constructs differently. Some Azure services are global. They're not even bound to a region. Azure Front Door, Azure Traffic Manager, Azure DNS, both public and private, they're global. They are globally available. Azure AD, globally available, or at least a very large region area. I don't have to worry about some region level deployment. So Azure AD, Front Door, Traffic Manager, DNS. Most though, especially a compute service, a storage service, they're going to be deployed to a specific region or regions that I can specify. Maybe it has some native replication and I can specify. But even within the region, maybe it's regional. Regional means it deploys to a cluster in a data center. I have no idea which one. So it's regionally deployed. I don't know what blast radius or exactly where it is. A certain cluster goes down, my service is probably down. It could be zone redundant. If it's zone redundant, Azure has taken care for me of its resiliency. So if we think, for example, let's take this for example. So if I did just a regional deployment, it could be anywhere. I have zero clue where that is. If I deploy it as zone redundant, what Azure is basically doing is it would just appear as resilient. It's zone redundant. I don't have to worry about it. It is taking care of making sure it's available. If any one zone goes down, it's still there. Behind the scenes, what it's doing is it's creating little instances in each of the zones. If it's storage, it has a copy of the data in each zone. If it's something like a standard load balancer, it has muxes and configuration of the software-defined networking in each of the zones. But for me, I just say deploy this thing. I want it zone redundant. I don't have to think about anything else. The other thing I can do is zonal. So zonal is when I create the resource, but it's pinned to a specific zone. So for example, a VM, I could create it in AZ3. It exists. No, I don't want to use the same color as the PBG. That's going to get confusing. Zonal exists in a specific zone, I say. Now, the benefit of that is I know this instance is in AZ3. I could then go and create another instance in AZ2 and another instance in AZ1, which would then probably go in a certain rack. Because that virtual machine scale sets can use that fault domain 1. So although it's an availability zone level, it will also, if there's multiple instances in a zone, spread them out over multiple racks. If I can have a zonal, maybe it shows up on there. So it's my responsibility to create instances on each zone. Now, some services like VM scale sets, which AKS node pools are built on, I'll say, hey, I want it zone redundant. All it's doing is creating instances in each of the zones. So if I do create a service like a VM scale set and I say zone redundant, you can't have an instance count of 1. It has no way of creating a VM in multiple AZs. If I want to do something like zone redundant that's VM based or container based, I have to have more than one instance. So we can create an instance in each of the zones. So that's the key thing. So if I was to think about that architecture for a second, well, I need to make sure I don't introduce some single point of failure or some cross-zone requirement. So in my architecture, I might say, okay, I know I've got a load balancer. Well, make sure you use a zone redundant standard load balancer. That's now available across the different zones. Okay, then maybe I'm using AKS. So AKS has node pools. Node pools are built on virtual machine scale sets, which uses VMs. I can say zone redundant, but the key point here is I need to make sure I have at least, for example, 3 instances, and it would create an instance in each AZ. So it would create a zonal instance in each of them. Again, the overall service, I might say zone redundant, but realize that's what it's doing behind the scenes. And then maybe it's using a storage account. Well, my storage account, I would make sure I made it zone redundant. ZRS is the option, so there's data in each zone. So if a particular zone went down, there's no risk of my service going down. So don't introduce some dependency on something that's only in one zone or is regional, because that regional one could happen to be in this zone. So if I want to be resilient against a zone level failure, every component I deploy has to either be zone redundant or it needs to be zonal, and I make sure I have instances in at least 2 zones. So I have resiliency from anything. For example, there's a NAT gateway. Well, NAT gateway, today I can only do zonal. I can't do a zone redundant. Well, if all of these relied on a NAT gateway and the NAT gateway is only in this zone, if NAT gateway goes down, they all lose communication. So don't introduce some silly point of failure that's local to one zone. So we have zonal, and make sure all components match, don't cross. At worst, have it better than what you require. So that's regional. Regional, I use those constructs. But we probably want multi-region. Now, for true resiliency, I want at least 2 regions to be used. And I did a whole video on using multiple regions. It's very involved. There's a lot of considerations around it. As I talked about, regions are paired. It therefore does that serialized platform update to guarantee the same update isn't made at the same time. I might deploy in an active or a passive configuration. I have control on that, but it is going to depend most likely on my application. And it gets very complicated. I'll be completely transparent because it comes down typically to the data. It comes down to the database. Let's give ourselves lots of space. I'm going to go all the way over here for a second. Let's say we want to use 2 regions. So this could be region 1, and then we've got region 2. I have to think about how is my stateful data being handled. That's a complicated part when I try and use multiple regions. Because let's say at minimum, I've just got an app tier and a database tier. There's probably other tiers as well, but if the stateless doesn't change anything, it's the state that's the problem. So we have our application tier. So we have our app. And we have our database. Remember, the database is the state. And there's probably multiple instances. None of that matters for this discussion. Well, my application, let's say this is the primary. Because a relational database, and that's the kind of a key thing, let's say our database is relational, it's fairly hard to have more than one primary, a writable copy. So the application in the same region as the database, well, it's quite happy. It can do read and write to its local copy. Now, I do have a copy of the database down here as well. Remember, it's a different region. Because it's a different region, I'm replicating asynchronously. I do have a copy of the app as well running here. But the problem is it can't write. This is read-only. Because it's this secondary, this is a read-only copy. So it can read from it, but when it wants to write, it has to go to that copy to actually do writes. Well, what is this distance? It's latency. Now, many applications are read-heavy. The number of writes they do is fairly low, in which case this may be okay. It can afford the latency when it does the write. So does my app allow that? Okay, so maybe I can handle this. But I've done a write, and now I try and read straight away. It may not have replicated here yet. So now I have a problem potentially of consistency. Because I wrote some data, I do a read, it hasn't replicated here yet. I don't see the data I just wrote. Well, that's a problem for me. This is why, for a relational database, it's actually very common to see active-passive. Again, maybe it can handle this. There's solutions, there's things I might be able to do, there's checks I can do. There are things that I can do to work around this. But that's why you would typically see active-passive when you have those relational databases, because the app can't handle the latency. It's too complicated. So this is active. If there's a problem, it all fails over, and we just redirect the request to here. Now, I will point out another option is get a bite of a tasty Cosmos DB bar. I got this, I thought it was funny. So the point of Cosmos DB is it was born in the cloud. And one of the great things it lets you do is you can have multiple writable copies. Because what it lets you do is, yes, it's multi-write, because it has a configurable consistency. And what that lets me do is I can have something called, for example, session level of consistency. So all of the instances in the same region would all see the same thing, but then it would replicate to the other region as quick as it can. But it means when I wrote, I would get the same data back as the read in the same order. So Cosmos DB solves that problem, but realize it still can't solve the speed of light. I can't have, hey, that consistency and that instant replication. It doesn't exist. We always have to make some trade-off. The point is Cosmos DB lets me make that trade-off. I could have a certain partitioning, for example, of the data, and they can still both function, and then it would have to catch up afterwards. So that would be one way to potentially solve that issue. So realize the active versus active passive is a big part going to depend on what is my data model, what is my database. Make sure all of the elements are available in all the regions. Again, it's about understanding what are the dependencies, what are the things I need. Oh, there's some jump box I need to connect to it. Well, I forgot to create that in the other region. Oh, I use Key Vault. I forgot to replicate the secret. Azure AD is just going to be there. Whatever it is, make sure you've thought about all those things, but don't be wasteful. Especially if I'm passive, do I have to have it running there, or could I create it at the time of an actual failover? Remember, some things can't move between regions, like a public IP. I have to have some other service that's going to handle it. And then if I have multiple instances in multiple regions, I have to balance between them. I can't typically say to my client of the service, well, hey, use this URL or this IP to talk to region 1, use this other one for region 2. If you don't get a response, well, then try this other one. I need a global endpoint that the clients connect to that solves that balancing. And there are different solutions to solve this. One of the earliest ones, and still a great solution, is Azure Traffic Manager. So Azure Traffic Manager the board is starting to get laggy. Azure Traffic Manager is DNS based. So it has its own name. I can hide the Traffic Manager name with an alias to my own domain. But basically, the client will query the DNS name. And what happens is Traffic Manager has targets. So the application, they probably have a regional load balancer to distribute here. Well, this points to IP or fully qualified domain names at the possible targets. And if I use the performance balancing mode, which will direct them to what one has got the lowest latency to them, it will return this as the resolved name and IP. So this would be performance. Hey, go and use the one closest to you. And that's a really good option to have because generally we care about the end user experience. So this is going to work. And because it's DNS, it's pretty much going to work for any type of service. But we don't get a huge amount of benefit outside of it's going to redirect us to the closest one. So there's other solutions. So the next one, and this is really nice, if I'm a layer 7, I'm sort of HTTP, HTTPS, is if we think for a second about the Microsoft backbone. So Microsoft backbone, I've got different deployments. I've got different deployments in different regions, for example. Maybe I've got 3. Let's just draw that. Well, the Azure network, yes, it has regions, but it also has huge numbers of edge locations, points of presence, that it maybe connects to other networks, that it offers different services. But there's all these different edge locations all throughout the world. So with Azure Front Door, which was actually an internal service used for things like Xbox and Bing, this is layer 7. And layer 7 sits at the top of the stack, which means it's HTTP, S, and HTTP 2. So it's only going to work for those web-based workloads. And the way this one works is the user, the client of this service is somewhere, but what Azure Front Door does is it creates an Anycast IP. Anycast means the same IP address is available at every single edge location. All of them. So then I, as a client, request to the big bad internet, hey, I want to get to this IP. it will direct me to the closest edge location. But what front door does is, well, when you actually communicate to a service, there's a bunch of things happen. I have to establish a TCP session, then a TLS. It does it all locally to that edge location. It's not adding the latency of going to some service. And then when I actually make requests, then it goes and gets big chunks of data from whichever region is closest to it. It's doing probing to make sure which one's healthy, so does Traffic Manager. Traffic Manager won't respond with a location that's currently down or having an impact. So it would then actually go and get the data, cache it, and serve it up to me in chunks so I get a really nice experience. Another one is the cross-region load balancer. If I think about in each region, I have a standard load balancer going to the various instances of my service, and they have public IPs. This is another Anycast. So it's available everywhere. That when I go and talk to it for the request, it will then go and send that to one of the other standard load balancers that's offering the service. So there's different solutions to that global set of requirements, but hey, depending on my type of service, if I was web, I would absolutely go and use Azure Front Door. If I was maybe a more generic service, hey, I could use Azure Traffic Manager. If I can, hey, maybe the cross-region, the global load balancer is a solution. So there's different options available to me depending on exactly what is my requirement. Use infrastructure as code. When you are deploying your services, don't click in the portal. You're going to click different things. It's not scalable. It's not fast. If I use infrastructure as code, it's going to ensure consistency. It lets me rebuild very, very quickly. I can use policy to enforce consistency between different environments. So never think of, hey, I want to manually go and deploy this thing or create this thing. Use infrastructure as code. It's in my Git repo. I'm using pipelines to create. It's going to guarantee the best experience. So I talked about different types of replication, but realize there's also different places I can actually do the replication. There's the native application, like SQL, always on, availability groups. It can replicate itself. Domain controllers can replicate themselves. Maybe the native application just has a standby, so it's not active, but it's got its own native DR. Maybe if I was using Hyper-V, it could replicate the VM on-premise or to Azure, because when I think about DR, it could be Azure to Azure, it could be on-prem to Azure. I'm using Azure as my DR location, a very good option. So I don't want to pay for a second data center. I hope I never have to use it, apart from the testing we thoroughly do. I only pay for it when it's spun up, and maybe some license costs and data storage costs. Maybe there's some in-OS. I've got some agent running between the file system and the volume driver that captures writes and sends it somewhere else. Maybe it's storage replication. There's some native thing in the application or a storage area network. Storage space is direct. Maybe I just restore a backup. What is the recovery point? What is the recovery time objective? How long do I have? And how much data can I lose? Hey, I can lose 24 hours of data. Hey, just restore a backup. I have 2 days to get back up and running. Yeah, my backups I take nightly, and it takes me 4 hours to restore the backup. Hey, this is a really cheap option. I'll do that. What is the requirement? I don't need to over-architect. I don't want to pay more than I need to. I don't want to replicate if I can lose a day of data and I've got 2 days to get back up and running. It's the timekeeping app. No one cares that much, so people can re-enter their time for a day. Hey, let's save some money. Or I cannot do anything, and I leave the industry in disgrace. Not recommended, certainly an option to consider. Not really. And this is really the preference. I generally would think about these things in that order. So if this is all of my, let's find a new place on the board. I'm going to go over to here. So let's go back to 100%. So when you think about those layers on premises or anywhere for that matter, I can really think well, okay, there's the storage that I'm running on top of. There's also a hypervisor. There's an operating system. And then there's the app itself. And then on premises from a target, well, there's probably another storage system. There's going to be a hypervisor. Maybe it's saying in OS at the application level. So I could totally think about, okay, well, hey, the app could do the replication. That could be SQL always on. It could be Active Directory multi-master replication. The OS, there's different options on how I would think about storage replica. There's Scout solutions. Some mobility agent, I might do it in there. This could be something like Hyper-V replica. Hyper-replica log files. It could be in the Sandays SRDF. Generally, I'm going to get the greatest fidelity, the lowest data loss, if it's available at the app level. SQL always on is going to be better than replicating something at the hypervisor level. But realize what's required. This app has to be up and running to accept the request. So it's probably going to cost me more money. So it's what do I actually need? And that's going to extend itself to the cloud. So if I wanted to replicate to the cloud or cloud to the cloud, I have the same options. Hey, I've got the VM. Well, I could have the app running in a VM. So the VM has to be up and running. I'm paying compute cost, but I could absolutely do that. But then I'm paying for this VM all the time. And obviously it has to have disk. I'm paying for that all of the time. But that's one option. But another option could be, well, I do something at the hypervisor or in the in-guest that just replicates to the disk. For example, this is Azure Site Recovery. There's a license cost for this, but it's really going to be a lot cheaper than paying to have that compute VM running all the time. And then you only create the VM when you actually do a failover. So that's one of the key points that we think about. Now, remember, if there's no state, generally, why am I bothering to replicate? It's just not worth it. If there's no state, just have a process to create it. That infrastructure as code, I can create it whenever I need. But if I am going to just recreate it, if there was a failover, so I'm not paying for any compute, but in the event of a DR, I have to spin up the web tier. I have to spin up the app tier. Database tier has state that has to replicate. I have to do something different for that. But the other tiers, I'll just create it. Make sure you have what you need to create it. If they're container images and it's off of a registry, make sure that container registry is replicated to the other region. If I'm building VM images, I'll make sure that VM registry is replicated, that shared image gallery, the compute gallery is replicated to the other region. If there's configuration, most Git repos like Azure DevOps and GitHub, they're just globally available anyway, but make sure you will have access to rebuild the environment if you're actually going to rebuild it. So just a key thing to think about. Don't over-engineer. Don't replicate if there's no state. If I can just recreate it very quickly and it meets that recovery time objective, I can get up and running quick enough, it's going to save you a lot of money. And when you think about VMs, now, Azure the cloud, there's way more than VMs. But it's generally only VMs that we tend to worry a lot about replication. If we're using containers, we're using serverless, we're probably architected accordingly, and we're not so bothered about some individual snowflake that we have to replicate. But there are different solutions. Like from on-premises, am I running on Hyper-V? Or am I running on VMware or physical? There's solutions to solve that. There are solutions for Azure to Azure. So if I have a VM running in Azure, well, maybe I want to replicate the entire VM to another availability zone, or maybe to another region. So it uses the same actual technology as, funnily enough, VMware or physical to Azure. And one of the nice things about here is I might have multiple VMs that need to be at the same point in time when I fail over. So I can actually create consistency groups that have the same app or crash consistent recovery points when I actually failed over. Which brings us to, you do have different thoughts about the point in time. Crash consistent is the app in the OS wasn't really aware. Someone took the current state of the disk and copied it to somewhere else. Most things handle crash consistent just fine. App consistent is like the backups we take. where there's technology inside the guest operating system. For example, Windows uses the volume shadow copy service. When I want to take a backup, VSS has a series of components, providers, and writers that pause the app, flush any data out to disk, pause, quiesce any changes. I can take a clean copy of the data so I know there's not mid-transaction, and then I resume. So that will be app consistent. The downside of app consistent is, well, there's a slight impact on the app while I do that pause, while I flush the things out, while I take that snapshot. So very often we'll have a choice and we can configure how we do those. And I can actually even replicate from AWS to Azure. So there's different solutions. So if we were to draw these out, and we started to do that over here with the actual things in place, we can solve many different things. So we'll say once again, okay, well, there's Azure as the target. One of the things I can absolutely do if I'm Hyper-V, then you have a virtual hard disk, or VHDX, you have the VM. And what Hyper-V can do is at a certain interval, it's just going to replicate up via the Hyper-V replica log files to a VHD. So that's on to the technology we're going to use is Azure Site Recovery for all of this. This is on an interval. It's, for example, I think it's 30 seconds, and I think it's 5 minutes by default. But it's just copying to a VHD. There's no VM running. The only time a VM runs is, well, if you actually fail over, then it creates and attaches in the event of failure. So it creates it at failover, which means I'm not paying for compute charges until I actually perform a failover. That's a key difference between, hey, it's just running all the time. Obviously, I couldn't do that if it was app level. App level, DC to DC, SQL to SQL, Oracle to Oracle. It'd have to be running and I'm paying the compute charge all the time. Or the other option is I'm running on ESX. I'm running on VMware, or I'm running on physical, bare metal. Here I've got the OS, and I've got the app. There's a file system, there's a volume driver, and the way this works is there's basically something injected between the file system and the volume driver. You have the idea of a mobility service. And as a write comes down or a change comes down, it's hijacked, is also sent to a component. Now there's a configuration server which hosts a process server, or there's now a new, for VMware, an appliance that's just really self-sufficient and contained. What this does is it sends those changes up to a VHD. It's really doing the same thing, but this is continuous. It's not on some kind of set interval. The end result, they're all copied into a disk and it creates the VM if I actually need it. Now for Azure to Azure, it's exactly the same real technology. Assume now there's another VM and it's got the app and the OS. What it's going to do is I want to enable Azure Site Recovery either to a different region or a different availability zone I can do now. It injects its magic, the mobility service via an extension, and it's just going to send the changes over here. And again, it will only create the VM if you actually perform a failover. I don't have to do this. I don't have to do the Azure Site Recovery. I could absolutely just have a VM running with the app in it. And I could do the sort of the SQL always on or DC. It depends on, do I want to pay this compute charge all the time? How long do I have to fail over? What's the fidelity I want? For a tier 1 database, for a domain controller, I would probably rather I'll pay for the VM and I'll let the app do the replication. If it's something less critical, well, if it's no state, don't replicate it at all. If I can, and it's not a unique snowflake, just create it as you need it. But hey, if I do need it replicated because maybe there is some unique configuration, hey, Azure Site Recovery may be exactly what I need. Don't pick one. Don't think, okay, I've got this 3-tiered service, got these requirements. What do I pick? Pick the one that's the right solution for any particular tier. Database tier, maybe I'm doing app level replication. the web and the application tier. Maybe I just create it on demand, but I've made sure I've replicated my container registry. My compute gallery is replicated so I can. My Git repo, my DevOps pipelines, I have agents available so it can spin those up. I pick the right one. Don't fall down to some lowest common denominator. It's really not going to be the right experience. It may cost you a lot more money than I actually need to do. If I use different technologies, the one downside is obviously the failover process. Maybe there's more considerations because now it's different things that are handling different parts of the overall solution. But Azure Site Recovery has plans. I have recovery plans that can actually call the different steps in an order. I can have someone needs to pull a great big lever. There's ways I can handle and solve that challenge. So don't think, oh, I have to have just one solution because I want to have those different elements involved. I can still have different technologies and still have a big red button I can push. It will go and call the right things. So I can still automate. Do consider the cost. Money is a huge factor. What's my requirement? Balance it with what's the cost. Work out what's acceptable to the business. That's generally just the way we're going to do it. You can cluster. I'm not going to spend a lot of time on this. It's there in the deck. You can read it. But basically the idea is if I do have things like SQL always on or file servers, maybe it's more legacy workloads, except SQL is not legacy, obviously. You can run a Windows cluster in the cloud. Traditionally, it was complicated because most clusters have an IP address that would move between nodes that was offering the service. I can't move an IP address between nodes. So one of the things we used to do is add a load balancer in front of the instances. The load balancer would have the IP, and the load balancer would only send it to the current active instance. It could use a health probe to do that. However, we can now have something called a distributed network name, and that can be the cluster name object. So now, the distributed network name actually has the IP addresses for all of the possible nodes, and it will take care of sending it to the one that's currently active. The client can handle that, and so now I don't need the load balancer. So there are things that have actually improved running basic clusters in Azure. SQL Server, for example, takes big advantage of this. I can, if I need a witness, which I will for a regular cluster, I can use a file share, an Azure file share. I'd put it in a different region. If I have a 2-region cluster, don't put the witness in one of those 2, put the witness in a 3rd region. Again, that idea of the quorum. I want them separated to make sure I can always run. If I do need shared storage, that's getting a lot less common these days. I can use shared disk in Azure, which lets multiple VMs connect to the same disk. The exact number of connections depends on, is it a premium SSD v1, standard SSD, premium SSD v2, or ultra disk. For some of them, the number of connections depends on the size of the disk, but I think premium SSD v2 and ultra, I think it's just 15, no matter what the size. I'm sure that link I've put in there probably goes through the detail of that. But here you can see, okay, yeah, so for premium SSD, you can see, depending on the size, it's either 3, 5, or 10. But if we go and look at standard SSD, it's 3, 5, or 10. But for both Ultra Disk and Premium SSD v2, I can set the number for up to 15. So I could have up to 15 VMs connecting to the same disk. There are different types of disaster recovery. Really 3. Planned. Hey, look, a storm's coming. Let's stop things gracefully, finish the replication, fail over. I would not expect to lose any data. There may still be an outage, but it's not unexpected. It's a planned window of time when I perform the failover. That's the one we hope we have if we ever actually have to have a DR. Unplanned is, oh, look, where did that storm come from and where's the data center gone? We didn't cleanly fail over. We didn't get to stop a service and complete the async replication. And so there probably will be data loss. And because we didn't get to shut things down cleanly, it may be a bigger outage as we now scramble. People weren't ready. Scramble and maybe have to run health checks and fix things, and databases are dirty and have to be cleaned up to actually start up. So it's going to probably lose data and it's going to take longer to get up and running. And testing. Let's test it I don't want to impact production workload, so I may test it at the weekend or whatever, in case there ever is a storm one day. Don't neglect the testing. Again, that whole idea of, hey, we forgot this thing. You don't want to find that out in the event of an actual disaster. Make sure disaster recovery is part of your change control. Hey, we're rolling out this change to production. Are we also rolling out that change to our DR location? What is the impact? Hey, we're resizing these workloads in Azure. We're changing the service. Have we changed that same size in the DR, or the infrastructure as code for the DR build out has reflected that? Don't let DR get out of sync with your production environment. And I guess kind of finally, obviously backup. Backup is critical. Nothing replaces backup. Azure has two backup services. It has Recovery Services Vaults, which were the original, which was also used things like ASR, but now it also has Azure Backup for some of the new products. These can be used to back up applications and many different Azure components. In addition to hybrid, I can actually back up from on-prem OS instances, file shares to Azure from outside of Azure. And I can recover it as needed. Most of them will do Delta-based storage, so it's only saving the changes, not a full every time. And I can have different types of recovery points, the app consistent, the crash consistent, and I restore to the one that I need at any point. I can configure my own retention settings. So if we go and look, for example, so firstly, I guess, if we think about, there's a nice backup center. So there are different solutions, but Backup Center brings everything together into one pane of glass. Backup Center can span subscriptions. It gives me a really nice data-centric view of the backups, of the workloads. I could change to see, hey, I only want to see data on a particular type of workload. So it removes a lot of the complexity away for me. One of the nice things it also does is it can quickly actually show me, let me go over to my vaults, create a new vault. It will show me the services supported. So Recovery Service Vault, i.e. the V1 Classic, supports all these different types of workloads. The new Azure Backup Vaults support these three types of workloads. And one of the things you're going to see is, whereas the Recovery Services Vault was very focused on copying the data to its recovery vault, its storage, for most of these, it's actually more of an orchestrator. It's not really storing the data itself. Azure Disks is orchestrating, creating snapshots. Azure Blobs is orchestrating, creating snapshots. Azure Database for Postgres, it's orchestrating the creation of an agent to run pg dump to dump it to manage blobs. So it's more about that orchestration set of capabilities. But whichever one I'm using, we have these idea of different capabilities. If I go and look at backup policies, show me all the different policies I have. But one of the nice things I can do is I can set the retention. And you'll notice, or I can have, hey, I want to keep a daily for a certain number of days. I want to keep a weekly for a certain number of weeks, a monthly for a certain number of months, and a yearly for a certain number of years. So if I have various retention requirements, one of the great things I can do with this is I don't want to keep a daily for 7 years, but I could keep a daily for a couple of weeks, a weekly for a couple of months, monthly for a year, and an annual one, whatever, for 7 years. So I can optimize my spend by only storing the data I actually need to do. So these policies are really, really useful. The vaults themselves, I can configure the resiliency on them. Is it just locally? Is it copies over all the AZs in the region? Or I want a copy of the vault's data to another paired region. And I can often also do a cross-region restore. So I can actually restore to that paired region. And again, Backup Center provides me a nice view on that. As I mentioned, realize some services are not actually backing up to the vault. Some of them, the backup is acting as an orchestrator to manage some native capability. Realize native capabilities may be better. If I'm actually backing up using SQL's backup technology, my granularity of the restore is going to be much better than if I just back up the VM. because the VM backup doesn't understand the database. So again, we don't back up because we want to back up. We back up because we want to restore. So pick the right backup solution that's going to meet the requirements of my restore. That's what I always have to think about. So Azure Blob has nice snapshot. It has soft deletes. Even if I delete something, I can just bring it back. Snapshotting. I could take a certain snapshot of a certain point in time, but actually Blob now has a point in time restore. It uses a combination of a change log. It uses versioning. It uses soft delete. So I can go back to any previous point in time. I don't actually have to manually create snapshots anymore with Blob at all. There's also object level replication with Blob. So I can pick a different storage container to replicate it to. Again, realize that's a replication. It's not a replacement for backup, but it's getting it to another location. And then that other location, maybe I've then got the point in time restore configured for that. And I may just need a custom solution. Sometimes what's native won't work. There's AZ copy is a great utility. I could trigger it to run off of an Azure function to just periodically do something. This is becoming a bigger deal, protecting my backups. Again, those bad actors that try and encrypt all my data, what if I want to protect from some account credential is compromised? I don't want them to go and disable my protection or delete my backups. The first level is the control plane, role-based access control like anything else. Restrict the permissions that you have. Just because something's being backed up like a VM, something inside the VM has no ability to go and mess with the backup vault. It can't go and delete its own backups. But multi-user authorization, MUA, can protect an environment even if the backup operator is compromised. There's a new type of resource called a resource guard. This should exist in a different subscription. Definitely the backup admin should not have standing permissions to it. It can even be in a different Azure AD tenant. And it locks critical operations unless this backup operator goes and gets, for example, an approval for a certain time window. So if his account was compromised, they can't go and disable protection. They can't delete things. So a separate rule is used in PIM, for example, privileged identity management, that to get the role they need to do critical operations is really locked. They can't just get to it. And so what that looks like is, if we just look at this for a second, I can think, okay, I have my regular backup. This is my backup vault. So I have my backup. And I have my regular backup admin. Now that backup admin will, on the backup vault that they've created, they're using, they're going to have high permissions. So role-based access control, yes, that's my first line of defense, but they're going to have standing permissions. Maybe use PIM to restrict it even further, but they have permissions on the vault. But what I want to now be able to do is I create a different resource. What I'm going to do is create something called a resource guard. Now the resource guard has to be created in the same region as the backup vault, but it can absolutely be a different subscription. And it can optionally even be a different Azure AD tenant. The whole point is there's some compromise, some malicious actor. Maybe they've compromised a global admin in this Azure AD, but it wouldn't mean they can compromise that Azure AD. So we create this resource guard, and this has its own role-based access control, its own set of permissions. There's going to be a completely separate person that manages the resource guard. And what I'm now going to do, the backup admin, because remember, they're a good guy normally, they've not been compromised, they're going to say, hey, I'm going to take this resource guard and I'm going to apply it to my backup vault. And that's now any critical operation, something that would decrease the protection. So any critical operation, they have to first PIM up to the resource guard. They have to get permissions for this time window. It's going to be limited in time, has to get approved. So they're going to have to approve the request. they're not going to approve it if some bad actor, and it's going to help protect it from this. So the whole point is any critical operation they can't normally do. And so if we go and look, wrong slide, stretch over there, I can just go and look, and I can pick what I want to protect. If we go and look at resource guards, I could create a new resource guard. I could create it, again, it has to be the same region. So if I say East US, so there's East US, protect one. What are the operations? I can pick. So removing MUA, disabling soft delete, that's always enabled. I can't turn that off. But I have control about things like, hey, delete protection, modify policy, etc. And I can just go and create that. And then once that's created, I could then go to, we go back to, let's look at my recovery service vaults. I think this is in preview right now, so it's only certain regions, but I know it's East US. If I go and look at the properties, we can see I can turn on multi-user authorization. So I, as the backup admin, now notice I created that resource guard and I'm the backup admin. You would never normally do that. I need them separate people. This is my lab I'm showing you. But imagine I've now a completely different person. They should not be the same person. In no way should the backup admin also have permission on the resource guard. That breaks the whole point. But now what I could see is, hey, I want to protect with resource guard. And I could select the resource guard. I don't think it's shown up yet, but it would show up. I'd be able to select it, and then I'd be protecting it with that resource guard. So now if I actually wanted to do something, what I would use is privileged identity management. I don't want it as a standard permission. I'd have a PIM role assigned. I would have it configured that it has to be approved, so that other person would then approve it before I could actually leverage it. There's also the concept of immutable vaults. I can use immutable vaults. Actually, maybe that's the thing that's coming in East US. I can configure a vault as immutable, and what that would let me do is I can't reduce the protection. So I wouldn't be able to go and prematurely purge away recovery points before their defined retention. And I could even turn on the ability that the immutable lock itself is locked, so I can never disable it for the storage, for the backup vault. So if I go back over here for a second and look back at that East US, one of the options you saw was immutable vault. So I could turn on vault immutability. That would stop me reducing protection. I wouldn't be able to delete a recovery point ahead of its planned time, but I could also lock immutability, which means I could never turn it off. You'd have to really think about that. But that's now set in stone for that recovery vault. I'd never be able to disable that. So that is another option. And that's it. So as always, we covered a huge amount of content. As always, I hope this is useful. And I'll see you on the next module. Take care.